Welcome, everybody. We appreciate your attending our webinar today. It's DOCSIS Pre-Equalization, vastly powerful, often undervalued, and we have some really exciting stuff to talk about today. DOCSIS Pre-Equalization is exciting enough, but we also have a really exciting application that we want to tell you about that can be where we use the pre-equalization data to actually help you do proactive network maintenance. So that's our topic today. Before we get started, I wanted to give you a quick heads up that you can ask a question. To ask a question, you'll see on your screen in the panel a little arrow. You can open that out, and then you'll see questions down here. Just go ahead and type in your question at any time during the webinar. We will take those at the end of the webinar, and we'll answer as many as we can, and any that we don't get to, we will go ahead and follow up with you after that. My name is Rick Husey. I'm Vice President of Marketing here at Zecorum. My guests are Brady Volt, founder of Volt Firm and also NimbleThis, and Scott Helms, who is Vice President of Technology here at Zecorum. Welcome, guys.
Thanks, Rick.
Hey, good afternoon, Rick.
Again, we're going to be talking about pre-equalization today, which is a topic many of you may be familiar with already, but if you already have it on, you already know about it, don't tune out, because really the really exciting part about that is the tools that can be now used and developed to allow you to find impairments in the network before they start impacting customers. So we're going to be covering that today. Before we do that, I wanted to go ahead and take a quick poll here on how many people actually have pre-equalization turned on. So when you see this poll, go ahead and answer either yes, you do have it turned on one or more CMTS, no if you don't, and if you're not sure, just go ahead and answer not sure. Hit launch. So you should see a poll now on your screen, and we're getting some results in. We'll give it just a minute more. Okay, it looks like we've got most of the answers in. I'll go ahead and close that poll, and I'll just share the results with you real quickly. So as you can see, it looks like 63% have answered no, they don't have it turned on. 37% do have it turned on. All right, so that's good information to know. So Brady, why don't you give us kind of a quick rundown on just pre-equalization first, before we get into the PNM tools and what you can do with it. Why don't you tell folks about pre-equalization, what they can do with it, what it's good for.
Okay, Rick. So I kind of look at the world like this. You know, we have fire, sliced bread, digital watches, smartphones, and then DOCSIS pre-equalization. So you know, I'm really surprised about this poll at 63%. Don't have DOCSIS pre-equalization turned on, because to me DOCSIS pre-equalization is one of the super cool and powerful features in the DOCSIS standard, and it's been around since the beginning of the DOCSIS standard. So while maybe not as cool as a smartphone and digital watches and sliced bread and fire, it's still really amazing and really powerful. And it's also probably, you know, people don't understand what it does or, you know, how cool it is. But just by turning it on, you can get as much as I'll say anywhere on a low end as a minimum of a 2 dB upstream SNR increase, but you'll oftentimes see like a 10 dB immediate SNR or MER increase in your upstream. And so how does this happen? Basically, the cable modem transmits signals to the CMTS, RF signals, and the CMTS analyzes these RF signals. And there's particular signals, these station maintenance sort of handshakes between the cable modems and the CMTS that occur at least every 20 seconds. And so the CMTS analyzes these handshake signals, and if there's some impairment between the cable modem and the CMTS, when we turn on pre-equalization, the CMTS will talk back to the cable modem and say, you know, the signal you're sending me looks kind of bad. And instead of you sending me a bad signal, what I'd like you to do is pre-distort. You know, make adjustments to that signal before you send it to me so that when the signal arrives to me, the CMTS, it's going to look good. So you're going to make adjustments to your signal so that as that signal propagates through the impairment will impact that signal, and then the signal will actually arrive at the CMTS looking really nice. So what that means to the CMTS is that instead of the CMTS getting a bad signal, it's going to get a signal that looks good after going through the impairment. So we get a reduction of correctable and uncorrectable code word errors and improved SNR. And this means better performance for the subscriber, better performance for the overall network, and ultimately less problems.
So Brady, I'm dating myself here, but I remember my car stereo had little equalizer sliders on it. Is it a similar kind of concept?
Yeah, I mean that's a great analogy. So if we don't have the equalizer in the car stereo, we could have maybe a car stereo that sounds too tinny or doesn't have enough bass, but when you put that equalizer in, you can optimize the car stereo for the environment that it's in, and that's a great analogy.
Got it. So what are we looking at here? We've got, I guess, the spectrum analyzer output. Is that right?
Yeah, so this kind of gives us the essence of what a cable modem is doing for the signal when it reaches the CMTS. The signal on the top, that display, that's a spectrum snapshot of a cable modem signal that looks really bad when it reaches the CMTS. That's the top image. So there's a lot of negative tilt to the frequency response of that cable modem signal, and that occurs on this particular image of a cable modem that's really close to a diplex filter, and we're getting a lot of roll-off. So we turn on pre-equalization, and the CMTS tells the cable modem, when you transmit your signal, I want you to basically create the opposite tilt that I'm seeing as the spectrum analyzer, so that when your signal goes through these diplex filters, what's going to happen is when that signal arrives at the CMTS, it's going to be flat across the top. And we see that occur on the bottom image. So now, instead of the CMTS having a signal arrive at it that has a lot of tilt, it's going to have problems demodulating that signal. We'll probably end up with correctable or uncorrectable code word errors and poor SNR. We end up with a bottom image which is nice and flat across the top. The CMTS is going to be happy, and the subscribers are going to be happy because they're going to have a lot more data throughput and a lot less problems with things like voice over IP, for instance.
So a problem that would have been, or an impairment that would have been causing problems for the subscriber, suddenly those symptoms go away completely.
Yeah, it's gone. It's totally gone, and it's corrected by the cable modem doing pre-equalization.
So Scott, diagnostics tools like our TrueVision product or ServerSure or BBX or something like that that's looking at signals coming in, would they actually look improved in that diagnostic software?
Yeah, and that's actually one of the very few drawbacks to running pre-equalization is it can actually mask some of the underlying problems. Even though, as we can tell, the cable modem has corrected around being too close to this diplex filter, but that problem is still there. That problem still exists. It's just that we now have this layer of correction above the FEC in the pre-equalization that lets us kind of deal with that problem. But if that roll-off gets worse for whatever reason, then you're going to have an escalation of that issue to the point where the pre-equalization can no longer compensate for that. So yeah, you can turn pre-equalization on, and I highly recommend that everyone do it, even if you're not experiencing quote-unquote problems. But the one drawback is you suddenly see a lot less red on your display and a lot more green. And sometimes your technicians will go, I don't have any problems. All my SNR numbers look great. I don't have any correctable, uncorrectable code word errors. But that's because all of the work is now being done in pre-equalization. And there is a limit to what you can do with pre-equalization from that standpoint.
And Brady, I assume that's especially the case maybe an outside plant where you've got some kind of impairments that just get worse over time.
Yeah, I mean, it's so like as Scott's saying, we start to band-aid, we start to cover up these impairments, and one thing we know about the outside plant is it doesn't get better over time. It only gets worse over time. So if we do have an impairment out there, the pre-equalization is starting to cover up. Say there's, it's corrosion somewhere, it's a loose connector, it's maybe a crack in a cable, after some point, whether, we don't know whether it's going to be a week, a month, 3 months, 6 months, or a year, that eventually is going to break apart and become really problematic, and those cable modems are going to fall off a cliff, and we're going to have subscribers going offline. So that will be a problem.
Okay, so we're going to throw a curve here and talk about two different kinds of taps. Brady, why don't you...
Yeah, so in order to start talking about how pre-equalization works and move into some of the next portions of this presentation, we have to talk about taps. And as soon as we start talking about taps in the cable industry, everyone says, yeah, I know what taps are. I've got taps all over my plant. And when we talk about taps in cable modems, the digital taps, we're talking about something different than the mainline taps, the taps that are on the right-hand side of the screen. So we have taps that are on the left-hand side of this slide that we call equalizer taps, digital taps. These are used in the cable modem to pre-distort the signal before they're transmitted to the CMTS. And we're going to be talking a lot about taps, these digital taps that are in the cable modem. And I just want to bring this slide up because it's very important that we have a sort of a terminology discussion before we move forward, because we're going to be talking a lot about taps with respect to cable modem and pre-distortion. And when we say taps, many times moving forward during the rest of this presentation, we're not talking about the mainline taps that are used to drop cables into subscribers' homes.
So the only way that this tap on the right would have anything to do with an impairment would be if it was actually corroded or something like that.
So there's one time where a tap in a cable modem could relate to an impairment on a mainline tap, right, because we can see corroded taps or impaired taps using taps in the cable modem, and now suddenly we're saying, well, here's a tap on a cable modem that's showing an impaired tap on the mainline, and
a physical tap.
On a physical tap, and so our terminology can very quickly become mixed up, and you'll hear someone like me saying, well, there's a tap showing a problem with a tap, and it gets very confusing if you're not understanding that there is a difference in the lingo.
Right. Now, Brady, you know a lot about this stuff because you have worked very closely and still work very closely with cable labs, right? Why don't you tell everybody a little bit about what you were doing there in the group that's been working on PNM?
Yeah, so quite a few years ago, even before I was involved, there a bunch of really smart people at cable labs and people from the cable industry started a group called PNM, Proactive Network Maintenance. And the word proactive is really important, and we'll talk about that more later. But they weren't happy with the fact that we were just getting a 5 to 10 dB improvement in upstream SNR MER by turning on pre-equalization. They said, there's got to be more that we can get out of this pre-equalization data. And so they started to study the tap values in the cable modems themselves, that equalizer data. And they figured out, by analyzing this data, we can look at the in-channel frequency response under the cable modem. We can identify impairments in the cable plant. We can identify the location of the impairments. We can turn all the cable modems themselves into individual monitoring points and start to correlate them and really make extremely useful information out of these cable modems. And so that's what the Proactive Network Maintenance Group turned into. Today it's called Ingenious, and I love that name because I always think of like Wile E. Coyote and the Road Runner. Wile E. Coyote had the mailbox that said Super Genius, so that takes me back to the Ingenious working group. But the working group still goes on today. We're learning how we can take this proactive network maintenance into DOCSIS 3.1, so it's continuing to go on. But the whole concept behind proactive network maintenance, as we've talked about, we don't want to hide these problems and wait for them to fall off a cliff and then go fix them when we have a system outage. We want to fix them before we have an outage, before the subscriber even sees that there's a problem.
So here on the left, this kind of reminds me of the equalizer sliders. Is that what we're looking at here?
Yeah, so now we're talking about cable modem taps on the left-hand side. These are taps that we send an SNMP query directly to the cable modem. We pull those equalizer taps from the cable modem. There's a tap standing up very high right in the center. We call that the main tap. That's the tap where most of the energy is going through. Taps to the left of that main tap give us information about group delay in the return path. Taps to the right of the main tap give us information about microreflections and how far the distance to microreflections are in the return path. We then take that data and we take an FFT of it, a fast Fourier transform. It's a cool sounding math term, and that takes the time domain on the left-hand side and converts it into the frequency domain in the right-hand side. And that gives us our in-channel frequency response. So now we can see the corrections that the cable modem's making to the frequency response before it transmits that information to the CMTS.
So here's a slide that describes a little bit about what you can do with this tap information, right?
Yeah, so now we take the tap information, and as I said, those taps on the right-hand side of the main tap, they're kind of like distance. So and each tap is roughly about 85 feet in distance. So we have a couple taps on the right-hand side that represent micro-reflections in this case. And if we, I don't want to spend a lot of time on this slide, but we can say that we have a primary echo, and that's 4 taps away from the main tap, so that's about 340 feet. We have a secondary echo that's 9 taps away, so 9 times 85, that's 765 feet. Now there's another algorithm we can use to find out roughly where this impairment would be out in our outside plant. So now we use our strand maps to go locate this impairment. And we go in one way from the impairment, 765 feet. We come in the other direction, 340 feet, and X marks the spot. So we can get really, really accurate to determine exactly where that piece of cable is that a squirrel was sitting on the line chewing in on the cable, and now we have water leaking in, and we know exactly where to send a technician to identify the impairment.
Right, and I can see where that would be very valuable, being able to narrow that down as far as having to dig up cable or search manually, right?
Yeah, well, I mean, especially if the cable's buried.
Right.
It's sometimes a lot easier to find when it's an aerial cable, but when the cable's 3 feet under the ground and someone, utility company was out, a week ago digging on a power line underground, that becomes much more problematic to find these types of impairments, and this is when this application becomes a game changer to the industry, because we can find things, see things that we never had the ability to see before.
So we wanted to show an example of a PNM tool today. It's our Pre-Equalization Analyzer. So Brady, I guess really what you're describing, this work with Cable Labs, you and the group, a lot of the larger providers have been working on this for years, right?
Yeah, so I mean, Comcast is absolutely on the forefront of this and has been really spearheading it. They've been putting a ton of resources into developing and driving this application for more than the past 4 years. They've also been having tremendous success with it. And I did a presentation with them at this past year's Cable Tech Expo, and I mean, their big line over and over again is it's just money in the bank from them, because the savings that they get on truck rolls, on reduced CSR calls, and also on customer satisfaction going up, because they're just improving their overall plant.
Got it. Okay. Well, I know there's a lot of complexity in taking the information, the equalizer coefficients and whatnot, creating an application. So what we want to present today is an application or a solution for all the other providers that don't have the resources to be able to create something and develop it on their own. So Scott, I'm going to turn this over to you and let you go ahead and demonstrate Pre-Equalization Analyzer and what we can do with this.
Sure. So what we have here is we've just loaded up the initial map for one of our customers that's testing the software. And right off the bat, we can tell that we have roughly 4,500, 4,600 modems on the CMTS. And you can tell that we have a number of modems that we've identified as having problems. Now I'm going to do one thing while we're over here, which is I'm going to go ahead and hit a correlate function so that our correlation will be running in the background, and we'll get to exactly what correlation is and how it functions for you in a few minutes. But we can see a map that breaks down the individual problems. And my screen's, there we go, we refreshed. And we can see where we have issues. Now, in a lot of cases, you're going to want to come in and filter the map so that you're only showing the modems that have significant issues, either the red and the yellow or just the red alone. And then, of course, we can zoom in to see those modems and see where those problems are located in respect to them.
So, Scott, this is information that would, in a sense, be hidden from somebody if they had pre-equalization on. They wouldn't really know that these modems are out there struggling.
Absolutely, and like I said, that's really the only drawback to enabling pre-equalization, because even if your CMTS is pretty busy today, what this actually does, I mean, it's not like you're not equalizing already. You're already equalizing, or your CMTS is equalizing as best it can on the post side. So turning on pre-equalization, what it really does is it moves some of the load from the CMTS down to the cable modems. Really the only drawback is, yes, these will be hidden. So a normal monitoring system that's looking at SNR and MER and correctable, uncorrectable code word errors and all the other normal metrics that we're used to using just wouldn't see these modems as problems, even though we have some pretty substantial problems. I'm just going to grab one. You can see we actually have one of these frequency responses that looks really, really odd. So I'm going to use this customer kind of as an example. So what we have here is a really out-of-spec frequency response. And we can tell just by looking at the equalizer taps that we really have some pretty significant problems. Not only do we have a lot of group delay, which you can see to the left of the main tap, we also have a big chunk of micro reflections. And now this is in tap 9 and to a lesser extent in tap 10. So these are probably in-home problems. I want to show you guys something, because this actually really illustrates how well pre-equalization does in terms of correcting the problem before it gets to the CMTS. So I got two graphs here, or two panels of graphs. So here on the left, what we see is what the cable modem is sending. So this is what's actually coming out into the cable plant. And then this is what the CMTS is receiving. This is a nearly perfect signal. You can see that all of our energy when it gets to the CMTS is in the main tap. We really have nothing in the post-equalizer side of things that shows up in any of the other taps. So this is doing a fantastic job of correcting around all these distortions, all the impairments in the plant. Now, the bad news, you can see we're way out of spec here in terms of how far out our in-channel frequency response looks and how badly our taps look. So we're getting close to our limits of what we can do with pre-equalization. This guy has actually a little bit more room, but he is going to start having some additional energy in the other taps, and then eventually we'll start seeing other problems. But this is a fantastic example of how well the whole pre-equalization system works. One of the other things we can do is we can actually look at this data historically, and this lets us see several poles. However, in this case, I think we only have a few, but we have 3 in the database right now for this modem, and we can tell we really haven't changed. All of our in-channel frequency response lines are directly on top of each other. We really are very perfectly matched up. So this isn't changing much. This is a static problem. This is a problem that is specific to this customer, which is also something that's important to understand. Because we can tell that these problems are in the home, this is where we really want to focus. And in fact, if I look out here, I can see that my TDR numbers here are telling me that my problems are really at 167 feet or less. So the first thing is to go correct what's going on at this dropper in this install, and then that will let us clear everything out and see what's looking at. And that brings me to another really important point. As important as it is to be able to locate the problem with the modem here, you also want to know when you actually corrected the problem or improved it, because there may be multiple impairments on this specific modem. So I can hit rescan, and that will go get an additional set of information from the modem. Bear in mind that these coefficients, so you can see the refresh came in, these coefficients are updated between the CMTS and the modem every 20 seconds. So rescanning more often than that won't get you a different result. But you can rescan as long as you keep 20 seconds in between the last time. just to see if you found all of the impairments and corrected them. So it makes it very easy for someone to identify what's happened, fix the problem, and then verify that they have indeed corrected the issue. So I'm going to go back to our map very quickly, and I'm going to reload all of the points. And we're going to start looking at correlation. Now, correlation is one of the most powerful parts of the software. So I'm just going to grab, see if I can grab a nice looking correlation group here. This is a pretty good one. Okay, so basically what the system does is the correlation group identifies modems that show similar impairments. So it says the standing wave is impaired in a similar fashion and our coefficients look similar. So the idea is that these devices are being impinged in a similar way. And what this lets us do, when we go down, we'll look at this list of modems at the bottom. We can see we have 11 modems that are in correlation group 14. And we can see what our FAR TDR number is telling us is that we have a lot of modems that are being impacted by a span of cable that is somewhere probably from, I would say, from 350 to 450 feet. So what we have to do at that point is go to our strand map, start finding that strand of cable that has that distance, and start looking at, okay, what is common to all of these modems? What length of cable, what run is common to all these modems that has that length? And then we can start looking to identify where we have our energy outside of TAP 9 and 10, where we have our energy, and be able to determine how far away that is. Now, in this case, we're looking at most of our energy is actually in TAP 11. So we are roughly 55 feet into that cable. So in this case, if we look at a 350 to 450 foot span of cable, we are going to be about 255 feet from one end or the other. So we can isolate it down to a pretty significantly accurate location. If we had a secondary echo on this reading, we could even get more accurate, which is actually the example that Brady gave. You don't always get a secondary echo, but in many cases you will.
So what we're looking at here, this group of modems are all probably being affected by the same impairment. So you can use this tool to, like you say, narrow down where that is, find it, and fix it. And again, with pre-equalization on, people aren't necessarily seeing any impact from this, but you can go out and proactively maintain your plant and fix this for all those customers by going to one location.
Yeah, absolutely. I mean, you're preventing potentially 11 phone calls
or an outage at some point when it goes over the cliff.
Yeah, exactly. I mean, you never want to have customers being your monitoring system. That's absolutely the worst way to monitor your plant. So what we have are modems that, again, are probably not showing up badly in any standard monitoring system because their SNR and their MER are going to look quite good. But when we can look at the equalizer taps, we can tell that there is an impairment. We're just working around it. And so it becomes really important to go correct that impairment before it, as Brady mentioned earlier, it gets worse.
Yeah, I mean, it is likely that this impairment, and we need to understand what this impairment is. It's something that is an impedance mismatch that's creating a micro-reflection. So it's a corroded connector somewhere, a loose connector, a corroded center seizure screw, or it's a kinked cable, or it's a micro fracture around a cable. It's something in our plant that's only going to get worse over time. So this is when it gets into, do we want to be reactive and wait till it comes apart in the dead of winter or in the middle of the night, or do we want to be proactive and fix this at a time that it really is on our schedule, a time that is most effective for us to fix this as cable operators?
We got one question from the audience about how does this tool interact in DOCSIS 3 and bonded modems, and it's important to understand that all of this data is based on the upstream interface and the frequency specific to that interface. So if you have a cable modem that is on multiple interfaces, you'll actually get a display for each one of those channels because, as I'm sure everybody in the audience knows, it's entirely possible to have an upstream bonding group where most of your channels are behaving quite well for everybody, but you have one channel that's underperforming, and that's obviously the one you're going to want to focus on. The other thing that's interesting that I think people will definitely get some value out of is there's a very quick and easy way to pull up the report here that will show you these are all of your red modems, and you also get the correlation group that they belong to as well. And this is broken down by the individual upstream interface. So this becomes kind of your action list and something that you can either print out or email and have your technicians begin working on. So this is a good way to break it down again, because the upstream is going to equate out to a node or a couple of nodes.
Great. Okay. Thanks, Scott. All right. So again, just kind of a summary here of the benefits of this tool. Really, what we're looking at there in the application is that you can really, with pre-equalization, right away with just a command, one command line, I guess, per upstream in the CMTS, you can immediately improve the quality of service for your subscribers, which is a great thing. And then this tool, you can then reduce your operational costs and go out and fix things before they start to break. Of course, that's going to save you money. That's going to make happier customers because you don't have outages, you don't have people calling in. It's going to reduce your costs in your call center. So there's lots of benefits to this tool. What we want to do now, real quickly, wanted to just let you know that we will be at the NCTC Winter Educational Conference in booth number 616, and we'll be demonstrating this product. And then also, Scott, you're speaking there as well, right, on a different topic on broadband trends, is that right?
Yes, I'll be speaking on broadband trends. We have one other question from the audience that we wanted to address, which was, are all of the values coming from the CMTS? And the answer to that is no. We get information from the CMTS about the post-equalizer side of things, but the pre-equalization coefficients are all stored on the cable modem. And that is part of the implementation, is we have to make sure we can actually reach down to the private IP addresses of the cable modems.
Great. And again, you can send in questions now if you'd like those answered. We'll check those out. Let's see what else we have here. What is the command entered in the CMTS? How can we determine if we're using pre-EQ? Do you want to address that, Brady?
So it does depend on the CMTS. On Cisco CMTS, it's equalization coefficient. On Aris, it's
pre-enabled.
Yeah, pre-EQ enabled.
Pre-E.
Yeah, and on CASA, it's also equalization coefficient. So it does depend on your CMTS. You have to look at each upstream interface, because it's always equalization coefficient, or cable upstream 0 equalization coefficient. And you got to log into the CMTS. That's the only way you'll know if it's enabled or not, is by logging into the CMTS and looking for that. Normally some type of equalization coefficient.
So we have a question on, does this affect aggregate bandwidth from Brian Jackson? So the first thing is it doesn't. That you're not going to change your bandwidth. What it may allow you to do is increase your modulation, because it improves SNR. But that's going to be, it's always, as you're changing your modulation, you're always looking at how fast can I push it? Can I push my upstream quicker? The other thing is this is an upstream technology, so it's not really going to affect the downstream.
Great. There's a question about cost pricing structure. We'll get back to the person who asked that question, but I think we can say that very reasonably priced, especially when you're considering just the advantages and the cost savings that you can have from a maintenance perspective, just your operational costs, again, call center costs, avoiding repeat truck rolls, right, Brady?
Absolutely, yeah. I think it's something that is definitely. I keep using the word game-changing, and I think the feedback that we get when you look at what Comcast keeps driving is that it's just money in the bank.
Can older CMTS use pre-equalization? What's the cutoff there?
So so when we look at cable modems, we say, well, DOCSIS 1.1 cable modem supports it. They just don't have as much resolution as DOCSIS 2.0 and DOCSIS 3.0 cable modems. But the one thing is a DOCSIS 2.0 CMTS, a DOCSIS 3.0 CMTS, they're great because they support DOCSIS 1X cable modems. However, I would not recommend trying to use this on a DOCSIS 1.1 CMTS because you're never going to be able to see any information, any 24 tap information from a DOCSIS 2.0 or DOCSIS 3.0 cable modem. You're going to be limited. Yes, it would work, but you're not going to have very good resolution as far as the in-channel frequency response. You're not going to have good correlation grouping or anything like that. I would only recommend it on a DOCSIS 2 CMTS or higher.
Mm-hmm. So there's another question related to calculating the values and how we display the data. So the first thing to understand, I think I understand the question. The first thing to understand is anytime you're dealing with mapping and trying to figure out where something is in relation to your plant and also the customer, is this does rely on GIS information, and it does rely on us having the idea of where the cable modems are at. Now, you don't necessarily have to load your cable modem locations into the system to be able to get the data, because if you just happen to know where your nodes are in your strand maps and which cable modem is where, you can simply take the tap values and calculate where the impairment is. The map's really a convenience. It's not necessary for locating where the impairment's at.
Okay, this question, are there any other parameters surrounding pre-EQ, or is it either on or off?
It's either on or off. Yeah, it's binary.
Yeah.
Okay.
How do you translate from the raw chart data to an action, like the problem likely at a tap 500 feet away?
Yeah, so there is a bit of training that's going to go along with this application that will help you make those decisions and help you interpolate the data and take those actions. So I think training goes a long way with this application to help answer that question.
So it's pretty, I guess it's pretty evident, as we could see when you turn on, when you have the application running, that you can immediately see, hey, I got problems I was not maybe aware of. So that's pretty easy to see. Then it takes a little training maybe to drill down on where those are. Is that right?
Correct.
Yeah, in a lot of cases what we'll tell people is you really want to focus first on those people who have issues related to their drop or their install, because those are really easy to address from the standpoint of, oh, I have an in-home technician that I can send out, and those are your quick and easy ones to deal with. Your correlation groups will be something that you want to focus on later on, you can do it at the same time, but it's two different people in many cases, or two different groups. So the difference between what I have in terms of my red modems that are in a correlation group and my red modems that are outside of a correlation group, that's really the way I would focus on it. So if it's in a correlation group, it's going to be away from the home, and that's when you're really starting to look at the FAR TDR number.
Got it. Somebody's asking if this is an add-on to TrueVision, which is our diagnostics product. This will be integrated into TrueVision as a separate module, right. So there'll still be an additional fee for it, but we do want to make it an easy user experience so that you can pull the same data from within the same interface. Do we have a button for low-hanging fruit? I guess, in other words, where should I go first? Is that what they're saying?
We're actually going to be adding some reporting to make that a little bit easier. I mean, the current reporting is sorted right now by the interface. I think we're going to try and create some reporting. We've had a couple of requests around this that'll make it easier to identify, okay, these are the ones that are really problematic that you may want to focus on first.
Yeah.
Okay. And Scott, we have a question from Paul, who's one of our affiliates. He wants to know when he can get it.
So Paul, I'm glad to hear that question. I mean, it's available now. I mean, what we've shown you is live. This is on one of our other customers' networks, so it is available to be deployed. I would say probably turn-up time within 2 weeks. We're actually adding in some storage, some additional storage horsepower, and it has nothing to do with the software, but that I don't want to do a lot of turnips until that's in place.
Okay. And then somebody's asking, can they use this service if they don't currently use eCorum? And yes, this is, this can be a standalone service, just like you can get TrueVision only from us or other managed services. You will be able to get just Pre-Equalization Analyzer if that's all that you wanted.
Plans for a mobile app. Okay, so it's available. It will actually function on most tablets, Android and Apple today. It's a little harder to work with on the phone side, but that's something that we're working towards. Longer term, all of this data will be moved into the TrueVision application, so we'll actually have the same client-side rendering technologies that we have there, and then it will be available in all the markets there.
So they'll be able to use TechVision?
Yeah. I don't know if it'll be embedded into TechVision or if we'll have a separate app because the UI is a little bit different for what we need to do.
Great. Okay. Another question about cost. So again, we'll get back to those that are asking about cost on that. Let's see, what are your polling frequencies and retention times?
So polling frequency is kind of up to you, and you actually have the ability to control how frequently the system polls. One of the things to be aware is this by design is a limited polling. We're not getting a whole lot of data. We're really focusing on just the data we need from the CMTS to identify all of the modems and the interface they're on, the post-equalization data from the CMTS, and then just the pre-equalization information from the modems. So in many cases, people will initially have their polling set to maybe once an hour, which I think is the maximum rate right now. And then as they get things under control, they'll actually turn it down so that it's only running every 6, 8, or even 12 hours. It's designed intentionally to live alongside other kinds of management systems. Basically, everybody at this point is going to have something that they're doing, normal kind of SNR polling for their modems, normal kind of code word errors, and so the idea is that this doesn't perturb your existing monitoring system.
Okay, so again, if somebody's got ServiceShore or BBX or iGlass or something like that, this can live happily
side by side, right? How do you turn pre-equalization on? It depends on your CMTS, but it is a single line per upstream interface. In the C4, the Eris C4. It is literally cable interface descriptor, and then it is pre-eq-enable. If you hit question mark, you'll get it once you enter into the interface config.
And we can Robert asked this question, and I think we had one other. So whoever asked this question, we can
send it.
We'll send you an email with more details.
But unfortunately, it's not the same for all the CMTS vendors. It's different for all of them.
And this is something we can help support with when we would get the application in.
Right. Okay. I think we're about out of questions. So you do see on the and we'll again, if you happen to get any more in. Well, there's one more. Let's see if we get that. Is the database accessible to other diagnostic tools, or can this consume data from other sources as well? Well, it's not really.
So first off, direct database access is not something we would recommend. The data is in there, but like I said, it's not the way I would really want you to do it. But we are going to be exposing this information via API. So that you can both push information in as well as pull data out.
Okay. And we're going to have a copy of this webinar posted. You'll see up there on our website, equalizer.com. We've got /webinars. You can go and see some previous webinars, and we'll have this one posted here in the next day or two. There's also some white papers up there, one of which is by Brady, who's sitting here with us. It's about DOCSIS pre-equalization. It goes into the little bit more technical kind of stuff. You wrote that for SET, right?
Yeah, that was for Expo.
So you can download that up on our website as well. You see our contact information up there if you have any questions about that. So I think that's about it. We won't take any more questions live right now. We'll go ahead and respond, but I'll leave the webinar up and running here for a minute or so as those questions come in, and then we'll respond accordingly. So Brady, Scott, I really appreciate your time. Thanks for taking some time here to talk about this. It's a very exciting application. I think this is this is, like you said, Brady, it's going to be a game changer.
All right, thank you, and thanks all for attending.
Thank you.
Have a good afternoon.